Popcorn comes from, you guessed it, corn. And corn is a living thing. And all living things contain water. So when we heat up the corn, the water increases in temperature and starts to boil and creates steam. That steam pressure builds up inside the kernel until it can't contain that pressure anymore. And since there are weak points within the popcorn kernel, the kernel will build up pressure and then explode from all that built up pressure, and thus turn inside out and become that fluffy, golden thing that we love called popcorn. It is important to note that not all corn can become popcorn. There is a special type of corn called popping corn that we use for popcorn. Here are some of the materials that we're going to be using for today's lab. We need a balance, an Erlenmeyer flask, tongs, foil, and remember the foil is made of aluminum, not tin. There is a difference. Tin will actually break apart in your hand. And we're going to need a hot plate, a scoopula, and we're going to need wire gauze so that we could put our hot flask down on there instead of the table so it doesn't shatter. Thing is, we're going to need to start up our balance. First, we make sure that it's plugged in, that the electricity is on, and we also want to make sure that the red reset button is pushed in, because sometimes when your balance will not turn on, it's because somebody has hit the test button or it has actually popped out. Next, what you want to do is hold down the on button. If you just press it once, it's like the side of your smartphone, the power button there. You have to hold it down, and then the balance will do what I call its happy dance. It's going to need to count down. You cannot put anything on top of that balance until it says 0.00 grams. If for some reason the balance does not say 0.00 grams, you want to make sure to press the 0 button. Sometimes it's called the tare button. Just tap it once and it should reset to 0.00 grams. Sometimes we use that function if we want to subtract the mass of the flask, for example, and find out just the contents inside of it. Or if right now, like it says 0.01 grams and I want to reset it, I just tap that button. First, we're going to need to find out the mass of our empty flask. So put that on there. That is a 250 milliliter Erlenmeyer flask, but its mass empty is 106.35 grams. That's important because I'm going to need to subtract that mass from anything else that I put on there with that, because we only care about what's going inside of that. Sometimes you'll see the last number on there waver a bit on your balance, and that's usually because of the air vents and the air circulating in the room, and that will cause that last number to fluctuate a little bit. But whatever number it stays on, that's the one we're using. So now I'm going to put in 2 kernels. I'm going to be careful not to touch them with my hands so that the oils from my hands affect the experiment. So in order to do that, I just made sure that I used my scoopula to scoop out the kernels. Make your observations on what the popcorn looks like beforehand. We always want to make sure we're using our senses. What does it look like? What's the shape? What's the color? Describe it as if no one has ever seen a popcorn kernel before. And then I'm just going to place it in my flask. And we're going to record the mass of the flask and the 2 kernels. And then in order to find out what that would be, just the mass of the kernels, we are going to subtract the mass that it says right now, 106.62 grams, minus the starting mass of our flask when it was empty. And that will give us the mass of the kernels before popping. And then when we're going to pop the popcorn, we're allowing the water to escape as steam, but we don't want the popcorn to escape. So we're just going to put a piece of foil over the top, and then using our pencil or the scapula or my tongs, I'm going to make a little hole in the top so that the steam can escape, but the popcorn will stay inside. It's important that after the popcorn pops and we take the mass, that we take the foil off, since the foil was not part of my original mass when we took the mass of the flask empty. The green light tells us that there is power, and we're just going to turn on the hot plate to its hottest setting, especially at first, to get it warmed up as fast as possible. You'll see the orange light start to glow, meaning that the top of that surface is becoming hot. And remember, even if you turn it off and that orange light is on, you're never to touch the top. You're never to just grab the flask like that. It is hot. Hot things are hot. That's part of our safety. So we want to make sure that we use our tongs if we need to shake it at all or take it off in order to let it cool. But right now I'm just going to let it heat up and pop, and every once in a while stir it a little bit so that it doesn't get scorched or stuck in one place. Got a little bit burned. And there goes the other one. So now I'm just going to take this off. And we're going to let it cool down on the side before I take the mass. Alright, so make your observations about what the popcorn looks like right now. And then we're going to take the mass of it. Just have to make sure that my balance reads 0.00 grams. And now we're just going to take, with using our tongs, just because it still might be warm, but I should be able to pick it up after letting it cool. And I'm going to place it on here. And that is the mass of the flask plus the popcorn. This is after popping. Notice how we've lost mass compared to when we started. And that's because water has escaped as steam. Since we're using the same flask, we don't have to put the mass of the flask empty again, unless it really changed, or we broke the flask and had to use a new one. So there's the mass of your flask with 4 kernels. That's unpopped. And we're going to heat it up like last time, shake it around a little more so it doesn't burn, and record the mass of the popcorn afterwards. Here's 4 kernels. When removing the top here, you could really see the steam that we made by heating up these kernels, causing them to explode and turn inside out, is leaving that flask.
Oh no!
Here's the mass of 8 kernels before popping. Remember, this is including the flask. This is the mass of 8 kernels after popping. Here's the mass of 16 kernels before popping. Here's the mass of 16 kernels after popping.